Okay, so in the past couple of videos, we've been solving equations. Now today we're going to go ahead and look at inequalities. Now, when we're solving inequalities, we're basically doing the same thing as we did for solving equations, except we're going to use an inequality symbol, such as greater than or less than or greater than or equal to or less than or equal to, as opposed to just the equal sign with equations. Okay, so that's one of the differences. And also another difference, as you'll see, is that we're going to have to flip the signs when we're either multiplying or dividing with a negative. Okay, and I'll show you that in a few. But let's start with this. A minus 7 is greater than 32. I'm going to add 7 on this side, add 7 on this side. Rules of algebra says whatever I do to one side, I must do to the other side. So this cancels out to get A all by itself. So I know A is going to be greater than, right? Keep the signs the same. 32 plus 7. Now 32 plus 7 is just 39. So A has to be greater than 39. So if A is 39, then 39 minus 7, we're going to have greater than 32. Okay? Now, our answer cannot be 39, of course, because A has to be greater than 39. So let's go ahead and try a couple of examples. Let's try an addition one now. So x plus 3.5 is going to be less than 6. Now in this situation I have addition, so the inverse of addition is subtraction, so multiply by 3.5, subtract by 3.5, subtract by 3.5. I'm just going to go ahead and add those zeros up there so it can help me out. So x has to be less than, this is going to be 5 right here, and then this is going to be 2. So x has to be less than 2.5 in order to make this inequality true. Now let's go ahead and try a multiplication example. We have 3x is going to be greater than or equal to, have a minimum of 24. Now, let's go ahead and do that. This is showing multiplication, so I'm going to go ahead and divide by 3. Division is my inverse operation. So x has to be greater than or equal to 8. Okay. Now, let me go ahead and try one more, a division case. So let's say we have x over 5 is going to be equal to negative 3. Now, it's going to be the same since the negative 3 is on this side. I don't really have to flip everything. Let me go ahead and put a greater than sign. We're not doing equations, we're doing inequalities. So I'm going to go ahead and to get rid of this 5, I have to multiply by 5, and then I'm going to go ahead on this side and multiply by 5. So x has to be greater than negative 15. Negative 15. Okay, so as you can see, we're just doing the same thing for equations as we are for inequalities. And one of the main differences, though, is that we're keeping the inequality symbol. Let me go ahead and circle those inequality symbols here, here. As you can see, they are the same, and we're not doing equal to signs. Okay, but there is an instance in which that changes. All right, insert multiply and divide negative inequalities. So this would change a couple of things. So let's say we have negative 4x is going to be greater than 16. Negative 4x is going to be greater than 16. Now, I'm going to go ahead and divide. Let me go ahead and change that color. I'm going to go ahead and divide by negative 4 and divide by negative 4. So of course this cancels out. I have to take the negative sign with it, or else I have negative x on the side, which is not what I want. So x is going to be less than negative 4. As you might have noticed, I had to flip the sign. The reason being is because I just divided by a negative number. During class and during some of your activities, we're going to go ahead and take a look at a brain pop video in order to figure out why we're actually making this switch. Okay, so let's just try another example so that you can see it. Let's go with negative 6x is going to be equal to, let's say, negative 12 here. Okay, negatives on both sides, but what really matters is this negative on the side that has the variable. So I'm going to go ahead and divide by negative 6 and go ahead and divide by negative 6. So the negative 6's cancel out. And I'm sorry about that. Let me just switch this to an inequality, not an equal to sign, an inequality. I apologize about that. So what we have is x is now greater than 2. Negative 12 divided by negative 6, negative divided by negative is a positive. And of course we had to go ahead and flip that sign. Okay? Go ahead and flip that sign. Let me just circle that. Okay. Now let's try a division problem. Let's say that we have negative x over 2 is going to be less than or equal to 4. Now, we have a negative sign, but what this is basically saying is that the overall fraction here is negative. So I'm going to go ahead and multiply by negative 2 in order to get rid of this negative sign to get x by itself. And then multiply the opposite side by negative 2. Inverse operation of division is multiplication. So x is now going to be greater than or equal to negative 8. 4 times negative 2 is negative 8. Once again, I had to go ahead and flip the sign because I am multiplying by a negative number. Let's try one more example. X over 6, let's make that negative x over 6, is going to be greater than or equal to, let's try negative 3. Okay, so once again, I'm going to multiply by negative 6 because I need to get the x all by itself. So x is now going to be less than or equal to, and then multiply this side by negative 6, 18. X is going to be less than or equal to 18. Okay, and then as you can see, we've switched our inequality signs. Okay, so that's basically the main thing you have to remember for solving inequalities. Just remember it's an inequality, so we can't put equal to signs because that'll show equations. And also, when we're multiplying or dividing by a negative number, we need to flip that sign. Okay?